Hello guys, welcome back to my channel. My name is Shashidhar Chidanandmali, studying in Sri Venkateswara College of Engineering, Bengaluru, Department of Electronics and Communication, Section Astrosat, Subject Computer Organization and Architecture, Course Code BEC 306C, Semester 3rd Semester. In this video, I am going to discuss the concept of memory hierarchy, what is cache memory, random access memory, about secondary storage. Memory hierarchy is a fundamental concept in computer architecture. It involves multiple levels of a memory with varying speeds and costs, organized to optimize the performance and storage capacity. Introduction to memory hierarchy. There are three factors plays a very important role in selecting a memory. First one, speed. The higher level in a hierarchy, the faster the access speed, but also more expensive and limit the capacity. Then second one, cost. Memory levels are closer to the CPU are faster, but these are more expensive, while slower levels are cheaper and offering a high capacity. Then third one, about storage capacity. The capacity of each memory levels increases as you move down the hierarchy, with the secondary storage providing the largest storage space. Cache memory, it is also called as a temporary storage memory. First one, speed. Cache memory is a must faster than RAM, significantly reducing the data access times for a frequently used instruction and data. Then it's cache memory location. Cache memory is located between the CPU and RAM, acting as a temporary buffer for a data recently accessed by the CPU. Then size of a cache memory. Cache memory is a relatively smaller compared to RAM, but its speeds make an essential component for performance. Then type of a cache memory. Cache memory is typically implemented using SRAM technology. SRAM stands for static random access memory, which offers a faster access compared to DRAM. DRAM means dynamic random access memory. Cache levels and associativity. L1 cache. It is the smallest and fastest cache level directly integrated with the CPU, often used for a frequently used instruction and data. Then L2 cache. It is the largest and slightly slower than the L1, shared by a multiple CPU cores used for a less frequently accessed data. Then L3 cache. It is the largest and slowest cache level shared by the all CPU cores used for a infrequently accessed data, serving as a last level cache before accessing a RAM. Then coming to cache replacement policies, LRU. LRU stands for least recently used. The block that hasn't been accessed for the longest time is replaced. Then FIFO, first in first out. The block that was loaded first is replaced regardless of a recent usage. Then random. A random block is selected for a replacement, offering a simplicity but potential for a less optimal performance. Then coming to RAM. RAM stands for a random access memory. These are the features of a RAM. First one, data storage. It stores the operating system, programs, and data currently being used by the CPU, making it directly accessible to the processor. Then it is a volatile memory. Data is lost when the power supply is interrupted, requiring the OS and data to be reloaded from a secondary storage when the system restarts. Then primary memory. It acts as a primary storage space for the CPU, providing the direct and fast pathway for a data access and processing. Then access time. It is slower than the cache but significantly faster than the secondary storage, allowing a quick access to frequently used data. Here are the types of the RAM: SRAM and DRAM. First one, SRAM. SRAM stands for Static Random Access Memory. It uses the latches to store the data, offering a fast access times but requiring the more power and space. Then DRAM. DRAM stands for Dynamic Random Access Memory. Uses capacitors to store the data, requiring a periodic refresh cycles to the maintain a data integrity, offering a lower cost but slower access times. Memory addressing and access. Memory address. Each memory location is assigned a unique address which the CPU uses to access specific data items. Then data access. The CPU sends a memory address to the memory controller which retrieves the corresponding data and sends it back to the CPU. Then memory controller manages the memory system handling the address, translation and data access requested to the CPU. Secondary storage devices HDD and SSD. HDD stands for a hard disk drive. It uses a magnetic platters to store the data, offering a high storage capacity but slower access speeds due to mechanical components. Then SSD. SSD stands for solid state drive. Uses a flash memory to store the data, providing a faster access speed, high durability, and lower power consumption compared to HDDs. Comparison of memory technologies. Cache memory. It is the fastest one, more expensive, smaller in capacity and volatile in nature. Then random access memory. It is also fastest memory, moderate cost, moderate capacity and volatile in nature. Then HDD. It is the slowest memory, least expensive and largest capacity. It is a non-volatile in nature. Then SSD. It is a fastest memory, moderate cost and moderate capacity. It is also non-volatile in nature. Then coming to last part of the video, conclusion. In conclusion, understanding the layers of a memory hierarchy is a crucial for anyone involved in computing. As we continue to innovate, the future holds exciting possibilities for optimizing a memory and enhancing the performance. Thank you. If you are new to my channel, please like, share and subscribe.